Okay, let's get started. Welcome to DINRG, Decentralization of the Internet Research Group of the IETF. My co-chair is Licia Zhang, and I'm Dirk Kutscher. It's great to see you here today. Before we start, the usual housekeeping. Please observe the note well about intellectual property. So if you contribute anything on IPR, or if you see anything that's IP relevant, you are expected to inform us in a timely manner. Please also observe the privacy and code of conduct, and the anti-harassment procedures of the IETF that we are also following in the IRTF. The IRTF has a code of conduct RFC that was published recently, so 9775. This has some additional statements on ethics in science, for example. Please also check this out if it's not familiar to you. And then, we are doing research in the Internet Research Task Force. This is not about standard setting. So sometimes this gets mixed up because we are kind of, operating in the IETF agenda and apply some similar methods from time to time. But really, so it's quite different to the IETF. So this is really about research. We don't necessarily need consensus for decision making. And so we're much more open also to experiments and new ideas here. Okay. Please join our mailing list if you haven't done so. Just looking around, is anybody interested in taking notes today? So it's a very rewarding activity. Thank you very much. That's great. Okay. And then let's quickly check the agenda. So I think it's pretty cool agenda today. Very interesting talks. So we have 3 talks. The first 2 are about recent outage events and their relationship to centralization. So one by Indranee Gupta and then one by Nick Feamster. Sorry for the spelling mistake, and I'm seeing that. And then the third talk is by Gianpaolo Scalone about Beyond ECH. So it's kind of discussing the, let's say, trade-offs or issues in like privacy versus decentralization in the like ECH context. And the fourth talk is by Diogo Gises about a generic framework for building dynamic decentralized systems. And then you may have seen that there is a BOF later in this week on ATP, Authenticated Transfer Protocol. And so we thought it might be a good idea to allow for some bit more time to discuss a little bit the backgrounds of the trade-offs in decentralizing microblogging platforms, social media platforms. And so for that, we are very happy that we have a excellent panel that will discuss this for about 15 minutes later today. We want to introduce this later when we get to that agenda item. Before we start, is there anything else that people would like to discuss? Any requests for bashing the agenda? Great, then let's get started. And I bring up your slides, Ivan. Great. And now you should be able to control them yourself.
Let's test.
Okay. Welcome to DINRG, Ariel. You have the floor.
Perfect. Thank you. Thanks so much. And thank you for inviting me. I'm a professor of computer science at University of Illinois Urbana-Champaign. And even though I don't work on cloud outages, it's not my research topic. I have been following cloud outages for quite a while, and we do quite a few studies of cloud outages in my class. So the extended version of these slides will contain several other outages. They are available, the slides are available for you to look at. I'll kind of touch on those older outages because there are many common themes that emerge. Okay, here's the question to think about. Historically, which of the following root causes do you think is the leading root cause of data center outages? 1, power outage. 2, overheating. 3, human error. 4, fire. 5, DOS attacks. Now, you can take your guess here, but many of you will probably guess that it is human error, and it turns out to be the cause of about 85% of outages by some estimates, 70 to 85%. There have been various studies on it. Now, one of the reasons I bring this up is to make a contrast with the particular Amazon Web Services outage that we'll be discussing in great detail during most of this talk. So hold this thought and come back to it at the very end. Just as an evidence of some of the other outages that happened very early in the early days of clouds, here are some examples. In 2011, there was a pretty major Amazon Web Services outage that lasted 3.5 days and actually led to some permanent data loss. 0.07% of Elastic Block Storage ABS data was lost permanently. And the root cause for that was an operator, human operator, shifting traffic from a primary router to a secondary network router. 2010, there was a Facebook outage which lasted 2.5 hours. The only way they fixed it is to turn off the entire site and turn it back on again. That's not a luxury that many companies have, but Facebook in its early days had that luxury. Again, the root cause for that was that an automated system made an invalid change to a configuration file. This is very similar to the root cause for the most recent AWS outage, which we'll be seeing in the next few slides. Of course, there are many other sources too. So in 2008, The Planet, which was at that point the 4th largest web hosting company, had a transformer explosion in a data center, and that caused a multi-day outage. And it is also reported that some Planet employees shipped servers from one data center to another on the backs of pickup trucks, though that is unsubstantiated. There are postmortems for all of these on the slide, so you can look at them later offline. All right, so let's go into the most recent AWS outage, which was in the news just a few weeks ago. This happened October 19th to 20th. I'm going to go through kind of the timeline of the outage, and then we will come back and discuss the root cause of it at the end, and then we'll see lessons at the very end. So this outage occurred October 19th to 20th. Many AWS services were affected. This included Netflix, Starbucks, United Airlines, all of which were down in various ways. Several customers had bought smart beds, which were connected to AWS, and the smart beds essentially stopped operating at night when the customers were sleeping. There was a New York Times article on this. At the universities too, we suffered a bit because our Coursera platform, where we offer courses, was down, as was Piazza, which is where the discussion forums are. So it was a pretty wide outage. Subsequently, AWS published a postmortem, which is where all the information on these slides is from. There is no proprietary information on these slides. Everything is from the postmortem that AWS published, and also any updates that they published periodically. Again, it's not my goal here to say that AWS is a bad infrastructure. In fact, AWS continued giving periodic updates and kept its health dashboard fairly updated with what was going on. Fairly frequent updates were published. And they published steps that they're taking to prevent a recurrence of this kind of outage in the future. So let's go through the timeline. So a bit of background, all of you know that DNS is the domain name system. It's a directory of services where you can give it a name and it returns to you an address. The name might be a file name and the address may be a location of a server. The name may be an endpoint. The address resolves to an address and so on and so forth. So that's first part. The second is the DynamoDB is Amazon Web Services NoSQL storage system, essentially a key value store with weak consistency semantics. So nothing as strong as transactions or sequential consistency, but something weak like eventual consistency. And it's fairly widely used both externally as well as internally. DynamoDB uses the DNS to resolve endpoints. And in this case, what kicked off the outage was that the DNS entry for a regional endpoint for an entire region, US East 1 region, had become empty. And this is what kicked off the outage. So the entire regional endpoint dynamodb.useast1.amazonaws.com, which is one of their significant regions, that DNS entry was empty. So when services queried for the DNS region, they got nothing and they panicked. We'll come back later to what caused this DNS entry to be empty. That's also a very interesting lesson in outages. But for now, let's just go through the time. So this happened at 11:48 p.m. on October 19th, and all the systems in the US East 1 region connecting via DynamoDB panicked, and DynamoDB is very widely used by a variety of different applications. At 12:38 a.m., morning of October 20th, of course, pagers went off and engineers rushed to address the issue. They identified this and they applied fixes at around 1:15 a.m. At 2:25 a.m., all the DNS information was restored, and it was replicated to 3 availability zones by 2:32 a.m. At this point, you might think, hey, the outage is done. It's finished, right? It was fixed. But here is where one of the common characteristics of outages comes in, which is that the outages cascade. The Elastic Compute Cloud is, of course, Amazon Web Services' most significant compute offering, EC2. At 11:48 p.m. on October 19th until 1:50 p.m. the next day, which is almost, well, more than 12 hours, the EC2 API had increasing error rates and increasing latencies. And whenever new instances were being launched, they returned various errors, such as request limit exceeded or insufficient capacity. Why did this happen? Well, it was connected to the DynamoDB. The EC2 instances are managed by a droplet workflow manager, also known as DWFM. They call the EC2 instances or groups of them as droplets, so they have a manager that manages them. DWFM depends on DynamoDB. Because DynamoDB started failing, this cascaded to the DWFM. And so that's why the DWFM checks started failing at 11:48 p.m. More specifically, there are leases between the DWFM, the manager, and the EC2 instances, the droplets. And these leases started to time out between 11:48 p.m. on October 19th and 2:24 a.m. on October 20th. At 2:25 a.m., as you saw from the previous slide, DynamoDB was back online, but the DWFM did not consider the expired leases, the leases that had expired, to be eligible for renewal. That was just programmed into the DWFM. And so this meant that all of the EC2 instances in the US East 1 region needed to create new leases. These are thousands and thousands, maybe even millions of EC2 instances. So that's a very large volume, and this essentially overwhelmed both the lease system and the DWFM. And at 5:28 a.m., the DWFM was finally recovered by engineers after a lot of effort. And of course, at this point, again, you might think, seems like everything is fine. We are back. DNS is fixed. DWFM is fixed. What else could go wrong? Well, there was a flood of these new leases being propagated, and this overwhelmed the network manager that is inside EC2. So at 6:21 a.m., soon after, the network manager saw increasing latencies, and this again slowed down the creation of new EC2 instances and also the operation of existing EC2 instances. Finally, after a lot of effort, by 10:36 a.m., the latency started returning to normal latencies. And finally, at 11:23 a.m., engineers started relaxing any of the throttles that they had applied earlier. They applied throttles around 4 a.m., 4:30 a.m. And the system started returning to normal. And about 1:50 p.m., the EC2 instances, both current instances and the newly created instances, started operating normally. And once again, we have this phrase, is it over yet? I think, oh, it should be done now. EC2 is fixed now. But as you know by now, things keep cascading. So there's another service called the Network Load Balancer, or NLB, and this started seeing increased delays between 5:30 a.m. on October 20th until 2:09 p.m. The network state propagation delays affected the NLBs of some of the customers, not all customers, but many customers. Now, as a background, NLB is essentially an auto-scaling infrastructure. So it's an auto-scaled architecture that routes traffic to endpoints, which is EC2 instances. And inside the NLB is a health check system. The health check system is responsible for checking the health of the EC2 instances. And because, as you saw in the previous slides, the EC2 instances had been failing, this health check system started returning uh, failed results and alternately healthy results because the EC2 instances were overwhelmed. They kept alternating between failed and healthy. If an EC2 instance was detected as failed, it was removed from the DNS. This caused an overload to the DNS. If after some flip-flopping, the EC2 instance was detected as healthy, then this was added back to the DNS, again caused more load to the DNS. And remember, this is a time where the DNS is already overloaded. So this is creating even more load on the DNS. And of course, these extra DNS removals and additions are going to become much, much slower as well. Even though many of the previous slides, what we had talked about, affected only single availability zone applications, this NLB portion affected multi-availability zone load balances that were working across multiple availability zones. They saw increased latencies. At 9:36 a.m. on morning of October 20th, engineers disabled the automated health check system. That was the only way they could start to recover it. And they started applying all kinds of throttles there. And by 2:09 p.m., EC2 had recovered, and then the health check system kind of recovered as well soon after it, and the health check system was re-enabled after that. So that's kind of the timeline of what happened. But if you go back a few slides, you might remember that this was caused because of a DNS issue. Let's go back there just to remind you. Here. The DNS entry for services regional endpoint, the US East 1 entire region was empty. Why did it become empty? What was the root cause of that? So what actually happened is on the right side of the slide, and there is a more intuitive explanation on the left side of the slide, which is what appeared in the CNN article. So let's go through the right side of the slide. Basically, Amazon Web Services uses several automated programs which update the DNS. Some of these programs are called enactors. There's also a DNS planner, but we'll just talk about the enactors. And generally, these enactors are programmed to be very fast and make their DNS plans very, very quickly. These enactors are like agents, if you will, except they don't necessarily have machine learning, as far as we know. And so there is an automated program that affect the DNS. Now, in this case, what happened was that there were two enactors that were concurrently trying to update that DNS entry for US East 1 region, and one of them was much, much slower than the other. And there itself was the root of the error. So there was a slow DNS enactor that read the current DNS plans timestamp. So these enactors create plans for updating DNS and saw that it was an old plan old, and then it started applying a new plan new, but then it kind of went back to sleep because it was distracted by heavy overload elsewhere, not because the outage had not yet happened. It was distracted by heavy overload, so it was slow. Meanwhile, another DNS enactor, a second DNS enactor came along, a fast DNS enactor, and it created a new plan newest, and the fast connector replaced everything with the plan newest. The fast connector also detected that there was a plan new which had been created by some other DNS enactor, saw that it was an older timestamp, and deleted that plan new. Soon after, the slow enactor, which was asleep or distracted, came back and replaced this plan newest with its own plan new. It was like, yeah, that's my plan. I was working on it. Let me just put it back. But this plan new was already empty because the fast enactor had already deleted that new plan. And this is what caused that empty DNS error. So more intuitively, what happens, this is on the left side of the slide, is that let's say you have two students who are in a classroom and the teacher says, both of you work on a lab notebook. And so one of the students is distracted. As we know, students are very distracted by TikTok and whatnot nowadays. Or maybe they're just sleepy, they had a night out. The student works on the lab notebook for a while and then goes back to sleep. The other student is very fast. So student one is sleepy, student two is fast and enthusiastic. Student one wakes up periodically and does bursty writing. Student two fixes the student one's work by deleting anything that they had written a while ago. And that is what essentially caused whatever student one had done to be deleted, and student two's work was not was also not there. So when the teacher came around, the notebook was empty. And that's essentially what happened here as well. So that's one intuitive way of seeing what happened. So what lessons do we learn? The first lesson is that assuming your program, automated program or script, will run fast enough and that there will be no concurrency. There was no concurrency at all. This thing we saw on the previous slide was a race condition. And the race condition was never programmed in there because the enactors are typically very fast. But in that word typically lies all kinds of dangers, right? One of the most basic things we teach our distributed systems students in my class is that asynchrony is a way of life. And one of the fundamental tenets of asynchrony is that a process may be arbitrarily slow. And our students ask us, well, isn't it true that my laptop runs at the same speed all the time and my iPhone runs at the same speed all the time? Well, generally that's true. But when it doesn't, it doesn't. And for programs, that's definitely true. Programs can have very long outstanding queues. So this leads me to, again, repeat something I've said to students, that if you're working with distributed systems, you must take a distributed systems class. So you should be aware that asynchrony is a way of life and program for it. That would have prevented the root cause from ever happening in this particular case. The second, as you noticed from the slides, there were cascading causes that cascaded and kept the outage going. Had there not been dependencies between DynamoDB and EC2 and EC2 and the network load balancer, the outage would have resolved much sooner than it did. Of course, it's easier to say that than do anything about it, because these dependencies across services are a fundamental reason why AWS works. You can run up new applications and have them use services, and automatically those services use other services transitively, right? So what is needed is that when an outage happens, we need new principles and new ways to break these chains of dependency so that the outages do not keep getting propagated. And as far as you know, there is very little research in this particular direction. This is not very different from deadlock detection, where you try to break cycles, but there's no cycles here. There's dependency chains, and one of the challenges is that you cannot just get rid of the dependency chains, because that's why the dependency chains are why the services are able to operate and call each other. So this is a new open area which has really not been tackled in a systematic way by either academia or by industry. The third is that we kind of know how to address failures of servers, failures of individual processes. So this is crash fault tolerance, whether it crashes, or we can tolerate failures of malicious and unexpected behaviors, Byzantine fault tolerance. There are techniques for it, algorithms for it. There's a lot of replication, erasure coding, all kinds of fault tolerance techniques that work. Even rack fault tolerance is very well understood. But when data center and cloud outages happen, this is like those rare cases of very unusual diseases, unusual illnesses, which have no cures whatsoever. So this is a counterpoint to the previous one. Maybe there are no solutions to outages, and maybe we just have to, live with it and just expect that it won't get bad and the internet will not come down completely. The last point I want to leave you with is a counterpoint to the question I had at the very start of the talk, which is that until now, 70 to 85% of the outages have been root caused by a human error. But now, with increasing automated programs or agents, some of them with machine learning, some of them with LLMs at the root of them, it is likely that it's not likely, but these programs are essentially representatives of humans. And so these programs may also be root causing a lot more of these outages in the future. And many of you already know that LLMs have all kinds of issues with them, unreliability issues from hallucinations to whatnot. And these might cause even more outages in the future. So that's not a very rosy prediction. What this means is that we need mechanisms for specifying safety and for checking the safety of what these agents do. We need guardrails around these agents that would protect the cloud infrastructure from unexpected and unusual errors that might be the root cause of these outages in the future. With that, I will stop and see if there's any questions.
Okay, cool. Thanks very much, Indy. Let's see whether we have questions. Please use the queue system if you have questions. Okay, I don't see any questions right now. Then let's think about this more, and please give your questions to Indy on the mailing list. Yeah, thanks again for doing this. It's super interesting. Yeah, let's discuss this more in the future. Thank you.
Thank you.
Okay, we are moving on. Just a moment. I need to take back the control first. Okay, so the next talk will be by Nick Feamster. We're very happy to have him here today. It's about a previous paper that he published with his colleagues about measuring the consolidation of DNS and web hosting providers. And Nick, wait a second, I give you control. Yeah, here you go. Okay, we are ready. Welcome.
Great, Dirk. Are you planning to advance the slides? I can certainly prompt you for that.
Yeah, you can do it yourself with your cursor keys. I just gave you the control.
Oh, amazing. Let's see. Oh, that's great. Okay, great. Thank you. First of all, Leisha and Dirk, my sincere gratitude for inviting me to present. It's an honor to be presenting to all of you at the IETF. We did this work. It's a blast from the past, as you can see. It's from the archive timestamp. We did this in 2021. The paper was actually never published beyond archive because reviewers didn't see the relevance of it. But now I think we can perhaps agree that this is relevant. There is a thing, and when it comes to the talk, and thank you to the point of the talk, Leisha kindly pointed this out. All of the code and data for this I have and plan to make publicly available. But because the project never quite saw the light of day until a couple weeks ago, I really hadn't consolidated it and published it. And so I'm in the process of pulling together all the scripts and the data that we have, and I will make it available to this group and DINRG and to the public. Several people have already asked me, like, shouldn't we do this again? I agree. So yeah, happy to make all the measurement pipeline, etc. I'm planning to make that available. So we started off, and this was actually motivated by things that were being discussed at the IETF at the time, 2021. ISOC, etc. had really started to talk about the concerns of consolidation, and so we posed that question: how concentrated has the internet infrastructure become? By the way, I should also mention there's a paper of this title on archive. You can find it, and there's the archive identifier for it. It's called "Measuring the Consolidation of DNS and Web Hosting Providers." Good. So what we wanted to do is basically look at, as the title suggests, like to what extent are top websites or popular websites relying on a consolidated set of infrastructure to host the content. And we did that in two ways, kind of two different dimensions in two different ways. So we looked at DNS hosting, and then we looked at web hosting. And then we also looked at different dimensions of consolidation or fragility. One was like, if that service like AWS were to go down, would it be affected? Would the site be affected? Meaning, like, it's part of the site hosted there, but, like, you know, some objects, or, you know, maybe even the entire site is redundantly hosted somewhere else. We call that affected in our metrics. And then second dimension we looked at was just like complete outage. Like, no, this is the only place this site is hosted. Either all of the DNS or all the web hosting was like on one service, and so an outage by that service would result in the whole site going down. So we looked at both of those. We looked at the Tranco top 1 million domains and also the top 10,000 websites. Tranco is like Alexa. It's roughly, qualitatively the same kind of data set. It has some different properties, but you can think of it as like the top 10,000 sites. We looked at what authoritative name server was used for hosting. We looked at who was hosting the content. We did this from 6 different vantage points, and then we mapped out the infrastructure. The key findings here were that there were a couple dominant players, Cloudflare and Amazon. Especially Amazon was even more dominant among the hosting providers. I'll show the plots in just a minute. Hosting basic exclusive hosts for about 30% of those domains in that website, and then about 70% of those top million domains were using a single organization to host their DNS resolution. Which Leisha asked me to comment a little bit, like, how did we get here? And I feel like it kind of makes sense if you think about how anyone might typically, not anybody, but a lot of orgs might set up a website or a domain. It's like you register the domain with a registrar. They tend to offer you hosting, or they point you to a hosting provider, or they are a hosting provider, and then you basically click a button and you get hosting, and you use exclusively that. Similarly with websites, right? Like if you're using a content management service, whether it's WordPress or Substack or Squarespace or what have you, we didn't do the analysis of those intermediaries, but like one might that might be an additional interesting follow-up, is that, like, is there consolidation or dependency being introduced because I'm not paying attention to like the redundancy I'm creating when I basically make my website. I'm just using a CMS, but underneath that, like there may be other consolidation that's just like automatically happening. And we did not look at that, but I think, as Leisha asked me to kind of talk and speculate about how did we get here, I think that would be a very interesting place to follow up. It's like, hey, what about the sites that people are using to make websites? And also, I think we already know when we register domain names that consolidation is kind of automatic. You can see, like, more than half the web, depending on how you define the web, is hosted by just a few providers. Actually, not only the index page, but the external resources are typically hosted on those sites as well. And these trends were consistent across the 6 vantage points we looked at, which were globally distributed. If I remember the process of doing this work, like, I think we started with 1 or 2 vantage points, and then a reviewer said, hey, how do you know it's true, like, across the world? And lo and behold, the same shouldn't come as a surprise to anybody in this room, I think, but like the same kind of trends held. Apologies, I don't know if I can zoom this, or hopefully it's big enough, but I'll read it to you. So basically, we started with the Tranco top 1 million over on the left. Right? We did a DNS lookup for each of those domains. We did the full recursive, right? So we got the name servers all the way down the chain. We did DNS lookups against those name servers to see, like, what are the IP addresses of the authoritatives, right? And then we also got the A record, the IP addresses to the A record. So we have both sets of IP addresses. We then, for the top 10,000, because 1 million sites is a lot to crawl, we basically crawled the top 10,000 using Crawlium. We got the index page to get all the external resources off those sites. And then based on all those, so that's like jQuery, Bootstrap, fonts, trackers, what have you. So we had all of those URLs, all those domains. We did DNS lookups against all of those to get the IP addresses for all the externally hosted resources. And then we used Tim Cumry, who is database, to basically map all those IPs back to orgs. And then when I show you the org charts, like, which are next, and I know I only have like a minute or 2 left, we basically map those into autonomous systems and orgs from there. And that's how we basically did it. Like I said, and I'm about to show you affected and unreachable. So affected means, like, if something goes down, like if one of those, if Amazon goes down, something on that site is going to be affected. Right? Unreachable is like the whole thing is on that site, and therefore it's going to go down. So, I mean, actually, we did affected for completeness, but you can see that, like, most, and here's the domains, right? So these are these are DNS domains. And there's a fairly long tail here that's not shown as well, but you could see, that a significant fraction of those domains are exclusively resolved by Amazon, et cetera. Let me go to the next slide. Here is basically, who's hosting the name servers by organizations and we broke it out because we did the top 1 million domains. So another question that came up in reviews was like, yeah, but does it differ like in the most popular websites or like in the tail? Turns out no, that trend is like fairly consistent. So this doesn't show anything that I didn't show you on the previous slide. It's just to show you that there's no bias, in the most popular domains. That trend of consolidation is consistent across the top 1 million. Same is true if you look at it by AS, right? So this is by org name in the whois. This is by AS. Same trend. We then looked at like the index page, like how that's hosted. And again, similar trends there. You can basically see, Amazon again being responsible for like roughly about 20% of the index page hosting. Here it is again. Oops, that's slightly cut off, but the x-axis is like now because we're looking at the websites, not the domains. Sorry, I'm going fast here. So remember, I looked at the top 10K websites. You can see there's like there is a little bit of bias in the data, in that like some of the less popular sites tend to be like more exclusively hosted on Amazon or AWS. You can kind of see that there's a little bit more of a spread in the top 100. But again, like a lot of consolidation on those Amazon, Cloudflare, and very few sites. Right? Probably don't need to tell you the implications of this. We had to motivate this a lot in 2021. People were like, "What's the point? Why are you doing this?" So I think we kind of know now. I can probably even update examples. Right? It's no longer just degradation; it's full-on outages. I think there's another topic that I study a lot, which is censorship, moderation of speech, etc. And that's not the topic of today's talk, but I think again we have seen a lot of these things. Even we're here to talk about the AWS outage, but we've certainly seen a lot of cases where a platform basically just decides they're not going to host a piece of content anymore, and so they just take it down. So that's something. This was, I think, the first study. Like there have been a few follow-ups, including I think some that have been discussed in this group, but we did this way back in like 2020, 2021, and so this was among the first. We did both DNS and web. I think that's maybe others have followed up and done that, but this is fairly comprehensive at first. And then, as I mentioned, I don't have a pointer. The data is set today. I'm actually still pulling it all together because, literally this was in the graveyard until a couple days ago. But I am in the process of pulling that together on a website, and I'll make it publicly available. There's the summary, and I'll just leave it at that for any questions. Thank you.
Thanks so much, Nick. Yeah, thanks for sharing. And so we do have some questions. We start with Brian.
Hey, Nick. Great to see you. Brian Trammell, Google.
Hey, Brian.
How's it going? This is really cool. Extremely timely, maybe ahead of the time a little bit. The question I would ask, as you dust this off out of the graveyard, I don't think you looked at it, but there's two axes of like non-distribution or dependency, right? Like you can depend on everything on a single cloud provider, right? Which, turns out to be sometimes not the greatest strategy. And you can also, within that cloud provider, depend on one or multiple, I think AWS calls them availability zones, right? Like, so different providers have a different idea, but you'd be like in US East 1, right? And what we found out last week is there was a lot of people who just like clicked the default, went to US East 1 and didn't do anything else. And then like people who didn't get hit by this may have had stuff in other availability zones. The good way to, like, I don't think there's a great way to look at this. A good way to look at this would be for like IP location, right? Because the public IP is on most cloud providers. So I don't think you looked at that. If you did, it would be great to pull that into the paper. If you haven't, it probably makes sense to try, because I think that would be really interesting to cut this over those two axes. Yeah,
we didn't look at that at the time, and that's a really good suggestion. Obviously, I think like in light of what happened, I think it's imperative to look at that. I think it's interesting. It might even be in our data, right? Because we have all the IP mappings.
It's certainly in your data. So that's why I'm making the suggestion. I think it's an easy thing to do.
Maybe, right? Because I don't know if we have the trace routes, right? Like I don't know if they've remapped IPs, right?
Yep.
We have the IPs. So assuming that is stable, like we have that, but like I don't think we have the trace routes, but like actually this is a great suggestion. There's been interest in redoing this study or like maybe continuing to do it. In fact, part of why I resurfaced it and like why I was, again, thank you so much, Alicia and Dirk, for inviting me, because like several people said you should do it again. And I would love to do it again. Like I'd certainly probably not going to do it 100% alone. I think I would have missed this point had you not raised it. But I do think there's a great opportunity here, given that we have the data in the pipeline. I don't know, maybe there's a website that we can make that's just like a consolidation monitor.
Yes,
I would, for anybody who's in the room, including yourself, like I would love to redo it, not just for the paper, but just like to just have an ongoing report. I would love to participate in that. So it's an open appeal.
Awesome. I think that would be great. Thank you very much for doing this and bringing it to DINRG.
Yeah,
thanks, Brian. It's a pleasure to see you again.
That would be a great activity for DINRG. By the way, if we could just keep doing this.
Thanks. And for the working group leaders too, like please note that down. Like I'm very interested in like part of why I wanted to come was to resuscitate the work and like and keep it going. So please feel free to tap me for that.
Cool. Thank you, Pete.
So this is Pete Resnick. My impression is that Cloudflare and a couple of others are different in kind than AWS insofar as the difference between I'm committing my services to AWS and using all of these tools that are available as against maybe putting something in front of my website or in front of my services that backs up against DOS attacks and such. And some of your graphs, I wasn't clear on, are people like really using Cloudflare in the same way, and does that affect the numbers?
That's a great question. I mean, to sort of tighten it up, like, are we differentiating between front end and back end? No, we're not. Like, and so if someone were to use like AWS exclusively in their back end, but host it separately, we wouldn't have picked up on that at all. So I guess there's either some assumptions there or I don't want to say gaps, but basically we are measuring front end behavior, not like reliance. I mean, we didn't. Certainly the data that we have doesn't give visibility into like dependencies in the back end. We didn't do that. I think that would be a very interesting way to expand it. The gears are turning onto like how you get that visibility, but I think that's a really good point and a good distinction to make.
Thank you. Very interesting study. I think an interesting update for 2025 Internet will be to add the measurement also. Sorry, Gianpaolo Scalone Vodafone. Sorry, I missed the step. So a very interesting update for 2025 Internet will be the measurement of domains behind the ECH. I'm doing not so extensive study, but some study about the adoption, and what I've seen that there are 10,000 of domains behind ECH. So what probably we could see is a single IP address behind several huge numbers of domains. So maybe another dimension in the study. Thank you.
I see. Is that? But when you say ECH, do you mean encrypted client hello or like what?
Yeah.
That's the next talk, by the way.
Okay, I'm gonna stick around for that and get educated. Yeah, we didn't measure that. I think that's also a really interesting thing to add. I don't know, even when we did this, it might not have been quite as deployed. So I think that's super interesting. Good way to expand this. As I was mentioning, I mean, and thank you, Alicia, for the encouragement to pull it all together. In the coming days, I will make a website that has like everything we have, and I hope to further engage with the group here on these extensions, redoing the study, maybe having as an ongoing study. Etc.
All right. Next question by Christian.
Well, speaking of this question, Wiedemer, speaking of ongoing study, actually I'm part of an ongoing study done by ICANN to measure about the same thing. I pasted the URL of the ICANN site publishing the data in the chat, and yes, it's a very interesting thing to do. Our study at ICANN doesn't go so far into finding the dependency on the website itself. That's because ICANN was specifically interested in the DNS part, not so much the web publishing part. But I mean, yeah, we find the same kind of result. We have been running that study for 3 or 4 years now. And
yeah, I see you got a 2021 copyright at the bottom of the page. You probably inspired our work, to be honest.
Yeah.
It started around the same time.
And look, I mean, I'd be happy that we could collaborate and look at what we could do better, or give you ideas. I mean, and see what's going on.
That would be great. Let's start a discussion thread, either through DINRG, or if you want to do direct. Like, I mean, yeah, we don't need 2 sites, so like maybe we make our harness like available to ICANN, and we could find a way to continue to run our work and then augment the data that you have. I think that would be really cool.
Yeah, thank you,
Andrew.
Yeah, hi. Sorry, hi, Andrew Campling. Really interesting presentation. Good to see some data to confirm probably most of our prejudices about what the situation is. 2 thoughts really. One is on the risks. I'd probably add to that something around the surveillance. The intelligence gathering that this gives, the sort of power this gives to the operators of those sites is enormous, and you only need to see a change in their voluntary policies, and they can just decide to farm and sell a vast amount of intelligence. So the privacy sort of impact of that is really serious. And the other one, to put a slightly lazy label on it, is, if you like, that's the counter of censorship, I guess, is the sort of digital colonialism. I was thinking about, for example, how long it took to take down kiwi farms, despite the very obvious harms that were being caused. So it's just, it's the other side of the coin of censorship. It's the refusal to acknowledge problems being caused and to impose a particular worldview on everyone, whether they like it or not. So just to give a couple of
that's really interesting. I think I'm glad you raised the privacy and surveillance. Actually, sorry, could you say one more thing about the kiwi farms point? I wasn't clear if you were making the opposite point of like consolidation there, because like I agree that the consolidation poses like really serious privacy and surveillance concerns, but I'm not as familiar with what happened with kiwi farms.
Okay, so just really briefly, because I think the chair's probably conscious of time.
Sorry.
Using kiwi farms as just an example, where if a particular host site has a perspective of not responding to takedown requests.
Got it.
So kiwi farms was a particular example of some really obnoxious practices and content, but despite lots of requests to take it down from around the world, we won't get into the specifics, but that particular hoster just kept it up for an extremely long time. From their perspective, probably defense of free speech, but completely disregarding the sort of doxing of campaigners and so on, and other harms that were being caused, as well as other very difficult content that was being hosted. So it's an imposition of that worldview on others around the world.
Interesting. Thank you.
Okay, great. It's really fantastic. I mean, really nice insights, many new ideas for future work. Thanks very much for Nick for making the time today and for sharing this. And
thank you for having me. I'll stick around for the rest of the session. I look forward to learning more, and thanks for the talk in front. And again, sincere gratitude for the opportunity to present to the group. I hope this goes somewhere, and I'm looking to engage with DINRG and on this topic, and I hope we can give this project some new life. Thank you.
Okay, thanks. Okay, and we're moving on with Gianpaolo, and you have the clicker here. Let's see if you can control the slides. It's the right one.
Good afternoon, Gianpaolo Scalone, Vodafone. I want to introduce a topic that I was exploring, looking at ECH and the problems of privacy centralization that is posing. So ECH has some positive gains. So it is one more step toward the end-to-end encryption. It is not end-to-end encryption as it adds a new middle box, but it is making more complex or impossible for middle boxes to do inspection of the SNI, the domain name, because the traffic from the client to the client-facing server is fully encrypted. What remains visible to middle boxes is the source IP address, so the sort of the identity of the client. And moreover, what is visible to the client-facing server is the identity of the client and the destination server. So it is possible to do correlation and profiling in a central position. And this is the gap that I want to address now. So client-facing server is a sort of ISP for content providers, and it aggregates a huge number of content providers. Today, it is in early stages. Deployment is touching more or less 7% of domains. And already today, we have 100,000 domains behind a single IP address, so managing a huge set. And what is important is that this client-facing server has visibility both on the client IP and destination domain. So correlation and profiling is possible. The origin server obviously can see the source IP address and the destination because this is the destination that the client wanted to reach. So there is also a jurisdictional mismatch. Typically, a client resides in a jurisdiction and is subject to his local laws. In the previous situation, there was some concentration point given by the local ISP that was residing under the same jurisdiction as the client, and also they have a contract with the client. So the client eventually, if it is not happy with the conditions and if suspect that the ISP is spying or profiling, can change. And each ISP has a very limited visibility on the traffic. Let's see, at national level, a portion of national traffic. Now, internet is moving to a few, from totally decentralized or partially decentralized to a few global visibility points. So now, anybody in the middle doesn't have any more visibility on the destination, but the CDNs are concentrating visibility for a good portion of humanity. You could have a CDN that is able to have visibility over 30% of humanity traffic, meaning that it is possible to do profiling for that good portion of humanity, and that part of humanity typically reside under a different jurisdiction. So it could happen that privacy law protect citizens of the same jurisdiction of the CDN, but for citizens that are living outside, they are not even protected by privacy law. So eventually there could be profiling, court orders related to foreign citizens, and a lot of other issues with the centralization. So here what I want to explore are methods to avoid that the client-facing servers and the CDN can have visibility of this good portion of humanity. I've seen some potential ways, and obviously this is very early stages, so I hope that there will be contribution to this work to improve and find even additional ways. But one first thing that I was looking for is to have a randomization of source IP address, a sort of intelligent NATing, to avoid that the client-facing server can see a single client that is looking at different destination arriving with the deterministic NATing, so that his identity can be attributed to a single person. In this case, for example, if we have per flow randomization with additional methods to avoid also machine learning or other techniques to associate the several flows to the single customer, we could have some additional protection of the identity. This can be coordinated network side, and what is very important is that this mechanism that is different respect to other proposals such as MASC has to be sustainable from the economical perspective, because should have be implemented at planetary scale. So if it is not sustainable, it will be never implemented. It has to be simple. So my idea is that this is a new functionality over existing network elements. So I'm calling it CFR, customer facing relay. Some emphasis on customer because there is a contract in this case from the customer to his provider. And one of the mission of the provider is to provide some more source protection, privacy protection. And it is also important to avoid full proxies, to avoid to add additional cost, but also to avoid adding latency that is very important in modern networks. Other possibility could be a selection of CFR based on the endpoint if there is support from the operating system, and a directory of those endpoints. The function of the customer facing relay will be to decouple the source IP address from the encrypted transport and provide randomization and rotation without touching the ECH. So ECH is not something negative that has to be dropped. It can be enhanced, is one step, but is not the final step in end-to-end privacy. Where it is to be put, I think at ISP or network enterprise edge, because if it is put in any place outside there will be places where it is still possible to do correlation if there is some capture of traffic. And it is compatible with all deployment because it's fully transparent and is not changing the topology or the TLS semantic. So here, my question to the West chairs is if this is in the same direction as this working group scope, and if there is a possibility or need, what do you think how to proceed for this work? I started with a very initial draft that by purpose doesn't add a lot of technical description to have first the contribution and really open to collaboration.
Yeah, thank you, Gianpaolo. I mean, maybe let's discuss the technical content first and see whether we have any questions on that. So I see Christian on the queue.
Yes, yes, it's an interesting issue, and given the concentration, there are too many points with too much view of the data. The idea of hiding the source IP address, I think that's directly addressed by efforts like Oblivious HTTP. Have you looked at that?
Yes, but in this case, there is the proposal will add an additional proxy, so adding latency and adding a huge amount of cost, and doing it at planetary scale will be problematic. In this proposal, I'm trying to keep it as simple as possible by implementing new functionalities on existing network elements. So a smart NATing, a non-deterministic NATing that is intelligent enough to avoid the correlation.
The other problem you have with doing that at the endpoint is that you were mentioning IPv6 private addresses, but the privacy addresses do not mask the 64-bit subnet ID. And that becomes 64-bit of identifier, which is unmasked there. So it's really hard.
In this case, for IPv6, the elements could ask a set of fresh IP addresses to be rotated for the flows. So an IPv6 to IPv6 NATing, having a rotation of IPv6 addresses for different flows.
Okay, we should discuss that offline, I guess.
Yeah. Andrew.
Yeah, hi, Andrew Campling. I think one of the positives this gives, just building on from the last presentation, is it does give end user accountability to end users, because I've got no say in what pick your preferred CDN decides to do as an end user. Whereas in this case, potentially, I've got a contractual relationship with my ISP. So I've actually got much more ability to interact with them. And if I've got issues with what they've done, I've got recourse to them through a contractual relationship. So I think this is much better, much more accountable, which is good.
Comment?
I think this is my purpose, because the accent on customer is because there is a contract. There is a strong contract from the customer to the ISP, and there is a contract for the purpose of receiving the service from the customer to the end service. There is nothing, really nothing, from the customer to the client-facing server. He's not aware, but the client-facing server exists and is a concentration of visibility.
Another question?
Yeah, hey. I was interested by that concept of the jurisdictional mismatch.
Can you say your name?
Yes, sorry, Fig. And in some cases, the jurisdictional mismatch might be the point of using ECH. If you're in a place where the threat is actually your ISP or middle boxes from network providers in your country, like that's a common case to use as like DNS censorship bypass, to use a different jurisdiction's ECH service. This proposal kind of like brings some of that client identification back into the jurisdiction to like undo that. And I guess I was just wondering, like, is this intended to be used in addition to ECH so that you have like protection from like adding protection, or is it like instead of ECH?
Thank you. No, I said it in my first slide. ECH is one step more to end-to-end encryption. It's not the final step, one step. So I'm not challenging ECH. What I'm saying is that it is not complete and is giving a lot of power to the client-facing server. So with this proposal, what I want to achieve is the coupling of source identity and destination identity. So the client-facing server is protecting the destination, is doing nothing for the source, and could be harm for the source, because if there is surveillance, if there is some profiling for commercial, non-commercial, ethic reasons on the client-facing server, it is an issue. So the ISP is protecting the identity of the customers, two different protection points. More privacy, not less privacy.
Okay, additive. Okay, thank you.
Yeah. Okay, Arnaud.
Yeah, I will be short. Arnaud Tadei, Broadcom. So Jean-Paul, thank you for this presentation. I was exactly on the same point, that the piece I like is the jurisdiction mismatch, and I get the point of the previous intervention, but I could argue as well that today doesn't matter, because the jurisdiction that are toxic are doing anyway other things to actually block it or stop it or whatever. So, but the key point is to really redistribute and stop the centralization. I find it interesting, because if you take, for example, and it's a good thing that we had the presentation before on the concentration on web hosting and so on, because it links to each other, right? So Take, for example, the Digital Operational Resiliency Act of the EU. I would be just mad at looking at the numbers I got before, because they are just exactly killing the resiliency rather than bring it back to a place where we can increase resiliency by getting a distribution map to the jurisdiction. Because here you have a clear view of some countries want by regulation to make sure that the resiliency is under control for obvious good reasons. And right now, ECH in itself goes in the entire different direction, but you are trying to find a compromise here, or a way to get this back in the right place. So thank you.
Thank you. Totally agree. If we think of the case where a client-facing server is in a jurisdiction that is in contrary respect, for example, Europe, there could be a usage of it to add, to decrease the competitivity, to add latency, to restrict resource access. So it's a control point.
Okay, yeah, thanks, Gianpaolo, again. So regarding your question, so I mean, as you said, like, so ECH is in general a useful tool for protecting privacy. It's just, you know, the deployment realities of today's cloud services that create this like centralization problems. As to your proposal, so we think it's an interesting direction to discuss, and but we have also learned that, okay, there may be some additional aspects that should be, you know, analyzed more, and maybe also the deployment risks in like real-world networks need to be assessed a bit more. But we would like to encourage you and everybody who's interested to kind of continue this discussion on mailing list, and then we can figure out what we can do in the future here. So thanks very much for bringing this.
Thank you.
Thank you. Okay, bring up the next presentation. So the next presentation is by Diego Jesus. Is he in the room? Yeah. Okay. So we're glad to have you. So we tried to have this in an earlier meeting, but we couldn't fit in. So we're glad we can do this today. So a generic framework for building dynamic decentralized systems. Diego, welcome.
Okay. So can you hear me? Okay, great. So hello everybody. My name is Diogo Jesus. I'm currently working at Nova University of Lisbon as a research assistant. And first of all, thank you very much for allowing me to present my work at this session. And without further ado, today I will present a generic framework for building dynamic and decentralized systems. Nowadays, when applications are deployed, they typically follow this kind of architecture, where one or more centralized components, usually placed in large data centers and centralized infrastructures, provide some service to users while interconnecting them. While centralized servers benefit from easier state management while providing good user experiences, as we can see nowadays by a lot of applications, they can suffer from some limitations, such as single points of failure, lack of redundancy, and now more than ever raise different concerns regarding data privacy and the ownership of what we write and what is deployed. On the other end, decentralized architectures, by their nature and design, mitigate some of these problems, but have extra complexity due to the lack of a centralized controller. While achieving data consistency and synchronization in centralized settings may be easy in some scenarios, in decentralized ones where nodes behave freely and may at any moment enter or leave the network, such goal is not trivial. As such, in this work, we focus on exploring strategies to simplify the development and the management of these types of systems by promoting a generic framework for building dynamic and decentralized systems. This framework contains a set of abstractions, best practices, and ideas to help ease the development of these systems and build decentralized applications that are scalable and resilient. This effort culminated into the creation of an internet raft, which basically displays the architecture and gives some of examples on how to use it. As such, we propose that much of the complexity is hidden within different layers of abstraction in what we call the core. Each component of the core essentially gives some aspect to the system in order to give different functionalities to the developers. On top of the stack, we have the protocol layer. The protocols are the main unit of interaction within the system, and basically have the developer's logic and contain the application semantics. This design promotes modularity with the idea of having each protocol being responsible for a very specific task and compose different protocols to achieve more complex applications. Protocols can interact with other protocols running on the same machine or running on different machines. And additionally, they can also use some of the functionalities presented in the core to build more complex applications and behaviors. For instance, if one wants to build a simple storage application, it can do so by using a membership service that notifies a propagation service about the neighbors available in the network, which then interfaces with a storage protocol that provides some sort of API to the user. This allows us to make a clear separation of concerns in what is doing what and what is being done internally by the framework's inner workings. Protocols can communicate with each other by sending and receiving events. They essentially can do this by sending those events and can be notified when new changes happen on the different components of the system, as well as the message arriving from the network from other nodes. One typical challenge of these types of systems is to discover contact nodes. This means a node that's already participating in the system and can help the new node in joining. To try to facilitate this, the Discovery Manager offers different ways to discover and manage new peers. Essentially, it can provide different methods, such as, for example, MDNS, distributed hash tables, etc., which could facilitate the entry and the seamless integration of new nodes into the system. The resource manager, as the name indicates, validates and sees the differences of the different resources on the machine, as for example, CPU usage, bandwidth, storage, etc. During initialization, protocols can register which resources they wish to monitor, and then they will be notified accordingly when new updates happen on those resources. And finally, the timer module is just a small component which allows protocols to schedule tests to be executed after a while or at regular intervals. That is very common in a lot of distributed protocols. Then, handling communication in these types of systems can prove to be very hard due to the different nature of different communication interfaces. While in a robust and resilient environment, it may be viable to have a predefined established communication path between two nodes. In a dynamic one, such option may not be visible at all times. As such, the communication manager tries to facilitate this by using different communication interfaces. For instance, if a node is not being able to communicate with other node through a TCP connection, it will fall back to a UDP1 or even, for example, using Bluetooth if available on both devices. On the other hand, the configuration manager handles the node's configurations during startup and as the system evolves. First of all, during bootstrap, the node must be able to self-configure, and of course, as the state goes on, it needs to adapt accordingly to the changes in the system. And then, last but not least, of course, the security manager is a key component on our framework. It basically gives support to various components such as identity creation and management, establishing secure communication channels between the different nodes, and of course, just supporting basic security primitives to the different components of the system. Now, the various functionalities we propose in the framework open up the doorway to build different applications on different environments. First of all, in the case of swarm systems, where we have autonomous agents like drones or robots, in the Internet of Things spectrum by having heterogeneous devices that need to communicate dynamically. In the case of peer-to-peer applications such as decentralized file sharing or messaging, where nodes are connected in ad hoc networks. And finally, of course, in the case of Web3, by providing the way to have blockchain systems and deploy smart contracts. Nevertheless, the draft must overcome a few challenges to reach its full potential and be viable in a lots of ways. First of all, the design must be complete and capable of outlining the different scenarios we have outlined, while upholding the security and trust properties provided by the security model. Then, due to, once again, its wide range of functionalities, designing and validating an API that takes all of these into account is still a complex task we are tackling at this very moment. And of course, ensuring seamless deployment and integration across a wide variety of devices is still one challenge we are trying to handle in this very moment. When it comes to similar platforms to what we are proposing, Yggdrasil is an experimental routing library which basically focuses on giving basic connectivity to different nodes. On the other end, Lib peer-to-peer is much closer to what we are envisioning by giving an extensible peer-to-peer networking stack. While Lib2P is flexible and widely adopted, as we can see by a lot of implementations nowadays, it primarily focuses on the transport layer aspect, while our framework pretends to take this even further and allowing developers to compose different protocols of different categories to create more complex applications with a lot of functionalities already out of the box. Babel and its version for embedded devices, Microbabel, is a framework for easing the complexity of building and managing distributed systems, and it is at the moment the implementation of the drafts. While it already contains some of the functionalities we have presented into document and in this presentation, it is still being continuously updated to have more features and to be in compliance with the document. We continuously try to make new applications and demonstrators in order to see the feasibility in various environments and applications, such as is the case of decentralized storage systems, machine learning applications, for instance, to enable federated learning, and the messaging services in ad hoc networks where nodes don't have any kind of dedicated infrastructure or central entity. With this, I finish my presentation. I would like to thank you again for letting me present my work at this session, and I would be happy to answer any of your questions and, of course, your feedback. Thank you.
Thank you. And you have a question?
Yeah, thanks for the presentation, Roland Bless, KIT. I think this is a worthwhile thing to do, but have you actually looked at Valid?
No, I don't think so.
Because they have a very similar goal, actually. I can send you a pointer or maybe just to the list. So it's a framework written in Rust, and they try to do many similar things, like providing basic building blocks for building distributed applications.
Yes, thank you. Exactly. I would say that when we first started thinking about this, one of our main points was, first of all, looking at the previous work and our own experience, and in a way of trying to think, okay, what are the building blocks that we need to build these types of systems? And in a way as well, if I was new to this and I didn't have much experience, what would I need to create these types of applications without needing to dive a lot into it? So yeah, if you can send me that, I would be happily see it. Thank you.
Okay, yeah, thanks for bringing this to us. So I see it's your first time here, and so I hope you find more connections after the meeting. Okay. And I think people who are interested should read the paper that you mentioned, right?
Okay.
Yeah, I think it would be good maybe to, if you want to get more people interested, maybe on a mail list or somewhere, explain a bit more about the actual features with respect to decentralization. So I think that was probably more than you could share today.
Yes. Okay. I try to keep it very high level just to give a brief idea, but once again, thank you very much for your comments and for the time.
Thanks for coming here.
Thank
you. Okay, now we're moving to our panel. And Lisha, I think I need your help to moderate this.
So given that the AT protocol is coming to you want to have a question, or you want to just join the conversation?
I
Okay.
was just grabbing one of these.
Thank you. It's coming to IETF, so therefore there's kind of very interesting technical discussions with regarding to the basic design choices of developing a decentralized social application. And therefore, I think it's really our pleasure to have people deeply involved in this area, to have this discussion with the DINRG people here. We got Brian here, who has been the main developer, I guess, for the Blue Sky /AT. And we have Christine online, who also contributed to this, I would say, very interesting, but very deep conversation on what would make the design choices and what are the technical trade-offs. That's how we want to have all the people join here. And thanks to Ted, bring up this conversation into the DINRG research group, and DIN research group. So we posted a few questions for our panelists to express their kind of design decisions and considerations. I mentioned in the email exchange with you people that maybe not everyone here actually have a very good understanding about the specific protocol, like AT/Blue Sky or otherwise ActivityPub, which are used as examples for different design choices. I was wondering if you people can start with just give a few minutes rough description on basic ideas, then we can continue on to talk about how you made your design decisions, where is the centralized control point, the decentralized control point. You want to say something, Pat?
I was just going to say, since Christine was one of the document specification authors for ActivityPub, maybe she could speak to ActivityPub and Brian could speak to AT protocol.
Yeah. Oh, yes. Sorry, I forgot to do a proper introduction. Yeah. So,
do you want to start, Christine?
Sure. Is my audio going okay?
Yeah, loud and clear.
Okay, great. Hi, I'm Christine Lemmer-Weber. I'm co-author and co-editor of the ActivityPub specification. And indeed, Brian and I had an exchange that got a lot of public attention from my initial article and then Brian's response, and then I had a follow-up article. But ActivityPub is a decentralized network protocol. It's most well known for being used by Mastodon, but Mastodon is not the only adopter. So there's other applications such as PeerTube and a bunch of other. There's actually somewhere around 100 different applications. I think more than that at this point that have done implementations of ActivityPub, and it's got a lot of servers online speaking to each other, and it's architecturally best understood as kind of like a web-ish version of if you were taking an email-like approach and were applying that with HTTP. So you, if you want to be able to get somebody's profile, you can do, it actually does not require HTTP, but that's the default protocol that's used. So if you want to retrieve somebody's protocol, you would do something like an HTTP GET. If you want to submit something to someone else, you post to their outbox. So there's different users on different servers, and they're doing get and post messages to each other. And much like email, you have a message and it has addressees of who the to is, and so on and so forth. And that to can also include collections such as like a user's followers. So if somebody has a bunch of followers, they can send it out, and then it can fan out and send to the individuals who are meant to receive. So some decisions were made in ActivityPub, such as I think when we had this exchange, I don't want to get too far into the exchange, but I'll say some of the highlighting features here are that that you can see it as in ActivityPub today is that it's very focused on being able to be deployable via very wide network, without any one player pulling a very central position in it. And you don't need to know everything. You need to know the things that are relevant to your particular node. And I think that's the big distinguishing debate in some ways between myself and Brian and our posts is whether or not that's required. There are some aspects of ActivityPub that are kind of ActivityPub as it's been deployed, since it did very popularly get adopted by Mastodon. I'll note that a lot of the work that I did shortly after ActivityPub came out was around some things like adding content addressing and stuff like that, which AT-Proto actually has in its protocol by default. So anyway, that's enough of an introduction for now. I'll let Brian speak.
Thanks, Christine. Always good to see you as well. I guess you can't see me, but I can see you up on the screen. Here, I'll at least come wave. Hi. So there's a couple. So as a quick overview of authenticated transfer is also intended to be a multi-application protocol. So it's a social web protocol that allows different schema types and different application types that people can build on top of. It's also out of state. It's got a few tens of thousands of accounts registered in the network. There's a couple thousand hosts that are running data hosting, and there's on the order of dozens of somewhat more serious applications being built of different types. The large flagship application that currently kind of dominates the network is Blue Sky, who originally developed the protocol. So it started, unlike ActivityPub, which kind of started as a consortium of multiple existing projects coming together to collaborate. Blue Sky definitely started as a single company that did development internally and is now trying to break up to some degree and decentralize a somewhat centralized thing that currently exists. And so that's like the path is to break off and have more heterogeneity in the network as it goes. In terms of design goals early on, I think one, like a pretty big differentiator is that we felt that global public views were like an essential feature. So having consistent global views that everyone could see the same thing. So you could have aggregations and counts, or if you wanted to look up an account name, multiple people in the world could search for something and get the same search results. And these are just existing features of large centralized platform things like Instagram or Facebook or Twitter. And those are the use cases that we were trying to compete with and come up with a decentralized alternative to. And we are pretty committed to, I think a term we use is no compromises. So we want to have the idea is to be able to build other applications that like pretty completely replicate user experiences that existing folks out in the wild are used to, as opposed to convincing them to do different things. Like a good example is that, at least in the early days, Mastodon had a somewhat principle, then I wouldn't disagree with these principles, but they had to take that you shouldn't show interaction accounts, that this was not like a healthy thing to have like counts under a post. And for Blue Sky, we felt like it was important to be able to do that, or at least be able to demonstrate that you could build this kind of interaction of like how many consistently compute interactions on pieces of media and things like that. So there's this kind of global consistent views and no compromises on some of these user experience things without like trying to get into defending the value of those user experiences. Our philosophy is that we should be able to provide them to people that are used to them. There's a strong design goal is the ability to substitute and have people be able to move between service providers. So that could be your primary hosting location in the network, or it could be something like a search service where you can swap out a search service. A somewhat application-specific example is that within Blue Sky, you can swap out your feed generator. So like the algorithm that is used to present you with posts or recommend you posts and things like that. It should be modular. You should be able to swap those components out. And a little bit of this separation between like towards that swappability, the ability to move your account around without it breaking any of your social graph connections or other kind of relationships within the network. So those are some of the design goals. To quickly try to summarize kind of the architecture we came up with, the analogy I usually use, the protocol as it is today is all public data. So all interactions in the network are completely public. Kind of technical summaries, it's somewhat similar if you had a Git repository, a public Git repository, you write data records into them, which could be of various different schema types. They're just kind of little JSON objects. And the protocol serves to efficiently synchronize all of these Git repositories and they can be aggregated at large or small scale. If you're a small application, if you're only looking at blog posts, you could look at just the blog post records. If you're looking at all of the Blue Sky posts, you have to aggregate all of the Blue Sky posts. A consequence of that is that if you want to do a large view, you need to run a large server. There's a lot of content to aggregate and to build a big search interface over. We think that it's very important to provide that. There can be a discomfort around centralization where it becomes more difficult to run a server because you're providing a more difficult service, right? Indexing billions of posts is more expensive than indexing only tens or hundreds of thousands of posts. But the design of the protocol is such that there should still be competition. It should be possible. There shouldn't be any artificial barrier to setting up these large services, and that there should be a relatively large number of providers that have competition between them. So that's like a somewhat different vision of decentralization or competition, of like the number of nodes in the network and the resources involved.
So let me thank both of these folks for being here. I think I'm here sort of almost on false pretenses. I introduced the topic to Leisha, and she let me join the panel, so I very much feel like the Mary Sue in this particular fanfic. My own background in this actually dates a long way back to mailing lists. When I was at SRI back in the late 80s, one of my jobs was to maintain the list of lists, which was a list of all the mailing lists that were on the DoD network at the time. And one of the things that's been fascinating to me to watch this come about is to see some of the issues that we faced back then in using subscription-based message passing protocol to create social networks, which is really what those mailing lists were for the early network, have replicated themselves at much larger scales as we've come along. And one of the interesting things, I think, in particular, is what does it mean to have portability in an instance like this, right? So in a mailing list, your portability is if you change your identity, if you go to a new mail server, if you control your name because you're going to a new mail server but retaining the domain name and your email address, then all of your subscriptions go with you. You know, all of your mailing list subscriptions stick around. If, on the other hand, you're changing because you've moved to a new mail provider and you don't own your own domain, then one of the consequences is you have to resubscribe and recreate your social graph, in essence, from scratch. And what's really fascinating to me is both of these projects have tackled that. They have thought about what does it mean to recreate a social graph if you have to move. And I think ActivityPub does it in a very much like, what's important here is the social graph, and you move that even though your identity changes, because your identity is tied to the particular server that you're on, where I think the kind of more shared heap architecture of authenticated transfer means that you can change identity, but because you're controlling the mapping between the identity that the system sees and the identity that you present to others, you can change identity, but if you want to change kind of the core relationship to it, you have to maintain something externally that allows people to find you again. And so as I've been thinking about this, one of the things that really has struck me is that these two architectures have extraordinarily different implications for how people who need to be presenting using pseudonyms are. Because how it is you express control of your name is typically through something like owning a domain name, which is not something that's fully possible if you're using pseudonyms across, where using a social graph is. And I think the consequences of that are kind of interesting. And if I'm going to throw a question to the real panelists here, it's going to be, talk to me about what it means to move.
Well, I think that I should let Brian respond first, and then I have a follow-up.
Sure. It's a big, I mean, we or I at least on the protocol team, and I think the whole team thinks a lot about identifiers and references. And so this was exactly something that we thought a lot about. We thought about email addresses, we thought about webfinger like handles as they work in ActivityPub, and we thought about other systems and DNS and these other things. And we had a couple different principles that came out of this, but a key thing was to want to basically add a layer of indirection where you don't reference other accounts in the network by their hosting location or their network location. We add a layer of indirection. So you have an account, like a primary account identifier, which can resolve to a current hosting location, but it's not, you're not, like in an email address, your network location is embedded in the email address. A related thing that I think has come up and been a little bit of a, has at times been a challenge in ActivityPub is also, which we were able to learn from. We're blessed by being able to watch kind of like a lot of rollout of Mastodon and these other projects and see different things. Not to say that we've introduced our own problems and there's things to look at and learn from what we've built with authenticated transfer as well that hopefully like future generations will be able to learn from. But a big thing kind of a principle that we took was that you shouldn't make long-lasting, hard to change decisions when you're not in a position, when you don't have enough information. And a key point of that is when you're just getting started in a network. If you're just setting up an account, you're not in a good position to make a decision about which server to live on or what your identifier should look like. So you shouldn't have to make a semi-permanent decision right from the start. The redirect system in ActivityPub does give you, it's not a totally permanent decision forever, whereas in AT, you have to choose this persistent. We have two layers. We have a couple layers of identity. So we have these persistent account identifiers, which are you use a system called DIDs from the W3C, though we use only a very restricted set of DIDs are supported in the protocol, and that's a permanent identifier. And we usually, the analogy we usually make is phone numbers. So you get like you don't change your, this is a big regulatory change when you are able to switch between different providers and bring your phone number along with you. And that's what we want in AT, that you can switch your host around and you don't have to tell all your friends or make new business cards or go around to everyone socially and update them with their new phone number. Your phone number just comes along. Like people don't even know that you've moved. This is like a huge goal that we've maybe succeeded at too much, which is you can move your account around in the network and no one even can tell. You just can't look, if you're looking at another account in the network, you can't, like you can, go in the dev tools, you can resolve the identity and figure out what they're doing, but it's not clear who's hosted on the same instance you are or not, because it's the abstraction layer is been well separated in that way.
You might want to talk about how you maintain that abstraction layer as not being a source of concentration, given where we are.
Yeah, it's certainly one of the big. So it's like, where do you go? How do you resolve these things? In some sense, we didn't want to totally commit to this and hinge the entire system off one answer to that problem. So we use the DID system gives us that abstraction layer. There's a new DID method that we came up somewhat unfortunately titled placeholder because we didn't think it would stick around. We thought someone else would come up with a better system for this. And we've since rebranded that, but the DID PLC system is kind of like a minimal system that we think is auditable and self-certifying such that it's not, you don't have to trust any single party. Like you can look at these logs of operations against an identity and the identities are basically hashes. But as it is today, I won't deny that it is like almost all resolution traffic is going to a single directory. And we're taking some, we're doing some work to try to get that out of the organization into a different legal entity. We're doing some work to build replicas of that and try to get it along the DNS path, basically.
Yeah, let's give Christine a chance.
So I don't mean to be trollish about this. When I'm a troll, I'm only the friendliest troll I can possibly be. So I actually fully agree with this. And in fact, here, months before ActivityPub was published as a W3C spec, here's a document discussing about how ActivityPub was intentionally built so that you could use even W3C decentralized identifiers. Now, there's a big difference. You see Bumblefudge in the chat talking about this actually a bit. But there's a big difference between ActivityPub as deployed, which had a bunch of kind of areas that were flexible with it, and then kind of what ends up happening in practice, right? And I mean, something gets out there and then actually kind of congeals somewhat. There is no account redirection thing in ActivityPub. That's something that was introduced as a specific design in Mastodon. But there actually is a path to actually using decentralized identifiers in ActivityPub itself. At the time that I was pushing for this, there was very little kind of interest from many members of the implementer community to go down this path. So I agree with decentralized identifiers. And the other aspect I'll add of this is that here is actually, I think, the route to doing this that I think is the best. I put it in the chat. This is so when Blue Sky was in its kind of figuring out what organization was going to run it thing, there were a number of proposals, and Jay Graber and I actually co-authored a proposal that talked about exactly this. Jay wrote a number of different proposals, and I think that it was smart to go with the team that she did, the design that she did, and et cetera. Like, as in, I'm not fighting any of that. The reason I'm bringing this up is that this write-up actually talks about exactly that. What if you had ActivityPub and then you had content addressing? So you had decentralized storage, and there's two different ways in which that can end up coming in. One of them is that the posts can survive even when the server goes down, right? And that's content addressing, similar to what actually happens with Blue Sky posts. And also, you're probably familiar with this from IPFS, et cetera, or the really exciting ones like Tahoe LAFS and stuff like that. And that allows for posts to go down, and you still can refer to the same content. I actually did a write-up on how to do this, like a little mock-up called Golem, which basically showed that you can do the idea of content which survives on this network. And that's actually because one of the things that's in ActivityPub is it doesn't specify that you have to necessarily retrieve this stuff over HTTP. It would be possible to retrieve it over a different protocol. So I actually fully agree that content addressing is one of the correct components of this. And for me, this starts to actually get into some of, from my perspective, and I'm actually borrowing this phrase a little bit from, I'm blanking on his name at the moment, but basically, I think the right design is not ActivityPub or AT-Proto. It's kind of a combination of ActivityPub and AT-Proto. One thing that ActivityPub does very well is it allows for message distribution that you don't have to be able to know all messages, and because it supports directed delivery. And one of the things that AT-Proto does very well is that from the beginning, they had built-in content addressing, and that content addressing is the fundamental way in which things work. And I think that that's actually the right decision. From my view, what you actually want to do is something where you're doing directed delivery of content addressed messages. And it's even possible that maybe you've used IPFS and you've used like a mutable file. It's possible to put out a new copy of a file. So if you take an ActivityPub profile object and you have it stored in the way that you have like the mutable IPFS file style, right? And ActivityPub user objects are actually JSON LD documents. They're JSON documents, and one of the properties says the inbox, which is the place to do an HTTP post to. So if you take that style design, and instead of having a user's name actually being on an live HTTP-based address, you actually had it use something like a mutable content address system, then that would actually permit you to change where the inbox is when you would like to move servers, and the same identifier for the user would continue to work. So I actually believe that I have no fight in the way that AT-Proto chose to do this. In fact, it's closer to what I believe and have believed for since 2017 about how to do this type of stuff than the way that Mastodon did it specifically.
Thank you very much. One of the things that sort of fascinated me about this is when I look at the design that Mastodon actually seems to have deployed, I actually see a lot of echoes with the way the mail system worked 20 years ago. The message passing thing, and especially as you're saying, if somebody subscribed to a mailing list, it goes to the service where that inbox is, and if a different server has no subscribers to that mailing list, it doesn't go there. And that distribution mechanism, I think, had a lot of resource advantages in 20 years ago that were incredibly important for being able to create these communities without them consuming resources where there were no members of specific communities. What's interesting to me when I look at AT Proto, it looks more like how email has evolved after 3 decades worth of spam. Because right now, the number of kind of realistically large enough mail servers out there that can make sure that their mail is really heard by the rest of the system is much, much smaller. Because like it or not, all of the things you have to do to maintain a decent spam posture drive up your costs enough that it may not be a cartel, but it's a pretty small club. And when I look at what it takes to do, and if I might borrow your phrase of credible exit, what would it take to do credible exit of somebody who had a system based on a blue sky right now to something else? They really can't go to a system that's a whole lot smaller. Maybe 1 order of magnitude smaller, but not really small. You can't run one in your basement. And what's really fascinating about that is that may be actually one of the reasons that the attack surfaces of the 2 different ones are different. Because right now you can't really attack Mastodon effectively because it's so distributed that if you attack any single server, the rest of the system just stays up. Where if you attack Blue Sky, it's designed to scale in the way DevOps scales by having the kinds of resources behind it that means you can spin up enough other servers to withhold downtime from the attacker. And it's really fascinating to think of like, what can we do to blend these, as Christine was saying, into a system that has the advantages of both?
There's a bunch to unpack there, a bunch of interesting big architectural things that we haven't quite touched on. One is this kind of anti-abuse thing, so spam or other forms of like harassment, brigading, misinformation, these other things. And this is an interesting, I think some people criticize the like as deployed activity pub, or some people have expressed, like some trust and safety industry professionals are concerned about like, well, how are you gonna detect like state actors coming in because everything's so decentralized? No one has a global view, they can't detect things. I actually have felt like ActivityPub's done quite well. Like the model of like a series of federated communities, of interconnecting communities, but each one is small. Each one's kind of a town that can like introspect. There's a little bit, everyone's a little closer to their administrator, and that this has worked quite effectively. And there's things, I think a lot of instances have invite codes, and it's a lot harder to roll in with 100,000 bots in the ActivityPub network compared to the AT network. I think in some sense, there's a little bit more of a like default trust. There's a default relationship. Like to come into the network, you've got some relationship that you're gonna be on a server. And I think, I mean, I think it's still a bit of an open question, and there's some challenges, but I think that model is working pretty well. But I'd point out that's doing something that's a different set of goals than what we're trying to do with Blue Sky, which is to build like a truly huge thing where you can roll in 1 million people in one day. We have had days where we've had 1 million people on board into the system or have the whole thing grow, and that people are relatively strangers, and you don't need to have a friend who's an admin to come in and get a server or something like that. So they're doing different things, and I'd say on the AT side, our posture to abuse is a little much more like default untrust. Like default is like, it's a scary web out there. Accounts are kind of spammers until they've been proven not to be spammers, and we have to do somewhat more centralized. I don't want to say it's totally centralized, but like you get some economies of scale around spam and doing anti-abuse things. I would say that is in some meta sense, there is some, both on a somewhat technical level, but also on a just kind of professionalization level, doing content. Certain verticals of content moderation go well with spam. There's certain kinds of like abusive stuff. There's like doing DDoS stuff. There's like attacking kiwi farms or trying to take on kiwi farms, that kind of stuff. I do think is well served by professionalized, larger, better resource organizations. I don't think they should be globally centralized, but it's hard to do that at a small scale. There's another form, there's huge swaths of moderation that are like high context inter-community or intra-community stuff that's way better served at a small instance level that's done quite well in Mastodon. So on that, I don't know if I should pause and let Christine maybe respond to some of those kind of like abuse and moderation things.
Just quickly, sorry, Christine, just quickly. So if people have questions, we do have a mic line. This is at this desk. So that's
They have a mic line, but I stole the mic. So I'll go put the mic back. So if you join the mic line, you'll be able to talk.
So I guess there's several things here indeed, and I'll open up with the comments on email and the way that email has gone, right? And I think that this is an astute thing to observe. It's long been my concern that none of our systems, actually, I'm going to be across several fronts. I'm going to make the argument that none of our systems are really well positioned that are in active deployment to meet the threats that we're currently facing. Not ActivityPub with Mastodon, not Blue Sky with AT Proto. My view is kind of that we kind of need some new design work, and that's kind of the direction that my work has been over the last few years, is on that type of side of things. So we have an organization called Sprightly that's doing some of this work. I also put it in the chat, sprightly.institute. But I'm going to, instead of focusing on how we're trying to solve some of those things, I'm going to focus on the problem space. So it's indeed the case that that email has become, email is the best original decentralized social network that we had on the internet, right? It's like the original, right? And it's become a lot less decentralized. I used to host my own email server and I stopped. I stopped because it became too difficult to be able to do so. And I think that it's becoming, it's very, it came to the point where I was trying to start an organization. I couldn't get my message out to really key people we were trying to connect to, that I had to stop self-hosting email, because effectively that social network has gotten so centralized. We've seen other kind of scare stories about this, right? XMPP was a great example of this, right? Where XMPP, the hearts and dreams that many people had about, yeah, we got decentralized chat, and then like Google and Facebook come in and we're like, we're gonna win, right? And then they're like, we're leaving, and then we're like, oh, where is everybody I'm talking to, right? So for those of us who were alive during that trauma, those kind of memories stay pretty clear. So I think that actually there is a lot here that's about like who's allowed to speak to who, and the perspective that we end up having. What AT Proto is trying to do, I think, is take what is the maximum approach of kind of a God's eye view approach of doing that. And a God's eye view where there could be multiple gods in the system, right? Like you could have a pantheon of different gods kind of viewing the system, but it's not monotheistic, right? But it is this kind of high level view. And then there's kind of other approaches that you could take, like a more capability oriented approach, where it's things are more directed, and you kind of lean into the directed messaging approach. I think that one of the things that we haven't really talked about when I say that none of these systems are sufficient, Brian did bring this up a little bit about, like what happens with state actors and et cetera. We're in a really scary state right now. I think that no kind of 2005 onward style, like the last two decades of social network design, I don't think any of those systems are very well equipped to handle the world where ICE has an entire department that they that is just monitoring people's social media, right? And they're probably on the Fediverse. They're certainly have a full view of AT Proto and have one of their God's eye views going over the whole network, right? Palantir doing the same thing and everything. How are we tackling that? How do we keep activists safe in this era? And I think that that's the direction. So a lot of this conversation ends up being, kind of Mastodon versus Blue Sky type perspective, and that's fine. But that's not where my thinking is. My thinking is what's happening next to meet the threats that people are having today for a very big changing world, a world in which it's becoming more dangerous to be able to speak your mind online, and a world where any source of centralization is a very attractive threat in terms of of capture as we're seeing across almost all media. I will say positively on that front, here's something positive about Blue Sky. Despite my critiques of some of its level of centralization, Blue Sky is almost in many ways the only source of media we have at the moment that hasn't been fully captured, right? That like we're seeing more and more media being captured so that it's actually very difficult for independent journalism to happen. And so I actually think that that's really valuable. I'm going to cede the floor because I've been rambling for a bit.
So I'm going to give one quick answer. One of the reasons I started the conversation around pseudonyms was exactly this concern. And almost everything you're talking about how Blue Sky can be used to provide that kind of information is at risk if the people who need to provide it have to provide the kind of identity that's traceable. So if you're an activist, it's one of the biggest concerns you have. And I think Christian Wiedema, who said this in chat before I even got up, is we have two levels of threat now, one nation state level and one attention-based company level, right? Where the attention economy gives you one set of big tech actors who have risks for you, and then you have the nation state on a different side. So I think that there's a lot of design work to do here. And thank goodness this is a research group, and I'm going to hand it back to Alicia to tell us what our research program is.
There's one or two points I wanted to jump back to if I could. There's a point around like the need to have a God's eye view, and I think there's like a little bit of a perception of like how, and also this question of like, can you run it in your basement? Can you scale it down? I'd say we haven't, that was never a design goal for us, was to be able to do it. I would say some people have. We have a couple people here from the developer community. So Phil's done an incredible job with these little microcosm, these little generic full network app views that run on like a Raspberry Pi and index the whole thing. They have billions and billions of edges, and you can do these large network things on very small hardware. I think, and that's cool. I'm a little nervous, I'm not sure how that'll, if we 50x the size of the network, I'm not sure how long it can keep going on a Raspberry Pi, literally. But I think there's another participant in our, like another really beloved community member in the ecosystem is Rudy Frazier from Black Sky, and he has this vision of like the missing middle of these kind of mid-sized communities of maybe 5,000 to 100,000. So it's not looking at 20 people trying to run something in their basement, but it's also not like 100 million user, gigantic multinational conglomerate. And it's these mid-sized communities that have a lot of culture, they have a lot of interactions. It's a lot of people who aren't systems administrators. They're folks that want a good experience. And I'm quite confident that the architecture we've come up will serve those folks. I think you can have a 5,000 person community that fundraises a little bit and can get one server. And we haven't done a great job telling these stories, right? Blue Sky, to be frank, does have racks full of computers to run the stuff we're doing. You need some pretty big, expensive computers, but most of that is read load. Most of that is servicing queries. If we didn't have people doing so many reads, it fits on a really reasonably sized computer. And some of this is just the specific efficiency engineering we've done with the fire hose and with the design of the protocol that lets you actually aggregate billions of records from the entire network, and you can index the whole thing on like a $200 or $300 a month server. Sorry? Oh, boss. Yeah, sorry, thanks. So anyways, I mean, it doesn't scale down to individual scale, but I think you can scale down to these small communities. And I think that's like a vision and a kind of thing that we're trying to support. To give a quick final pitch before I hand it over, we have if you're interested to learn more about AT, we have a BOF tomorrow morning at 9:30 upstairs in one of the larger rooms.
For fairness, I think we should give Phil a few minutes as we are running out of time soon.
Yeah, great discussion. Just a quick point. At the moment, we're kind of like centered upon using the browser as the basis for social media. And, I like the web, but it does limit what you can do because you've got limited cryptographic options. If you really want to get serious about security and end-to-end, you start having to have questions like, who controls the private key for the user? And what I don't like about the current Blue Sky system is I don't have control of the private key. And what I don't like about Signal is I have to trust where the public keys come from. And what I would like to see is, starting from people who do have a private key that they can control, how can I establish a DID so that I hold the private key that is doing the signing authority, but I can then hand over control to you folk when I give you the ability to post on my behalf, but without giving you the whole enchilada.
I'd actually disagree that things are centered in the web browser. Most users use mobile apps, and they're using a smartphone. Their account is kind of rooted not by scale, at least in our kind of metrics of looking at Blue Sky. And you know, phones have secure enclaves on them and can generate keys. This is definitely something where we'd like to do more in HT Proto. So we have demos of like you can generate a key on a YubiKey and register that for control of your PLC identity or other pieces in the network. There's some engineering to be done. There's some product engineering to be done to make that a accessible, broadly deployed technology, but like there's definitely a path to enable that.
I agree that, yes, a large number of people are using applications, and that's the opportunity. The problem is that if you decide that there's going to be a way of getting in here with a regular web browser, as soon as you do that, that means that you can't have end-to-end encryption, because there's no way that your system can do that in the standard web browser.
Okay, great. So we have reached the time limit. I'd like to close with a quote by Alexis de Tocqueville, who said, "Decentralization is really, really hard." And I think if you've seen this today. So I want to thank the panelists, so Christine and Brian a lot, but especially also Ted for facilitating this, for coming up with the ideas, and for being so helpful with the moderation. So we think that so DINRG could be a really good forum for discussing these topics further. And so while, like, you know, the IETF may or not at some point, you know, standardize some elements in the protocol space, there are tons of questions that could be addressed in research. And so we hope that we could make a good contribution here in this group. So if people are interested, let's find a good way to do some constructive work in this direction.
I would just add one more sentence. Ted asked me to say this is a research group, so what should we do? I think the very first step in research is always clarify your problem definition. I think we need to first figure out what other problems. If we have clear understanding of that, then we know how to take the next step. Yeah, I think that this is the conversation is extremely interesting. Yeah, I wish we had more time, another hour, then we could go on to get more put on the table. But we really appreciate you people's help joining the conversation. At least we'll get this started. Thank you.
Thanks, everybody.
Thank you.
Thank you, Christine, for coming online.
Thank you for hosting me. Bye.
Bye.
Very nice. Thanks very much. Thank you.